All right, hi folks. This is Larry Mussolino. I wanted to record a short video as a continuation on some of the problems in the Module 5 assignment. I also wanted to show you how to get started in using what's called descriptive statistics in Excel, because you'll use that as part of the Module 5 project that I'll talk about in a few minutes. So let's take a look at this one. I'm on here. This is question number 20, and they're asking us, you have a normal random variable, mean 33, variance 16. Let's write that down, mean 33, variance 16. Now, if they give us the variance of 16, we can also calculate the standard deviation. Standard deviation is the square root of the variance. So in our case, this is going to be the square root of 16 or 4. All right. You're going to take a random sample size n. What sample size is necessary so that the probability that x bar is between 32.9 and 33.1, that probability should be 0.97. Well, the first thing I'm going to do is draw a diagram here so I can get a sense of the area they're referring to. And I'm going to draw here the mean, which is 33. And I'm noticing that the bounds they're giving us is 33.1 and 32.9. So notice this is symmetric because we're 0.1 above the mean and 0.1 below the mean. And they're telling us that this green area is 0.97. Well, if I know that area is 0.97, that leaves remaining area of 0.3 to split among the two tails. Remember, the total area under this normal curve is always equal to 1. So if 0.97 is in the center portion, it must mean the other 0.3 is split. So 0.15 is here and 0.15 is here. All right, well, I'm going to pick one of these values to work with. I'm going to pick, let's say, this 33.1 to work with. I can also pick 32.9, but I'm going to pick 33.1. All right, now, let me see the area to the left of 33.1. If I notice here, the area to the left of 33.1 is the sum of 0.97 and 0.15. So that area is 0.985. Now, what I'd like to do is work with the z-scores, because for this number 33.1, the z-score can be calculated as 33.1 minus the mean. Let me write the formula for the z-score here. You take the measurement minus the mean divided by the standard deviation divided by the square root of n, because we're talking here about sample means. So in our example, this is going to be 33.1 minus the mean is 33, the standard deviation is 4, and the square root of n, because we don't know what n is, that's what we're trying to determine. So if I could figure out the z-score, that would help me, because then I could solve for n. Well, what I'm looking for is the z-score. So I want to find the z-score that cuts off this area of 0.985 to the left. Well, for that, I could go to one of these normal tables that my math lab here is giving me as links. Let me come to this table right here. And I'm going to go looking for the area of 0.985. I'm try to move it over here a little bit. And if you notice, if I come into this table, I am seeing 0.985 right here in the table. Well, this corresponds to a z-score of 2.17. So z equals 2.17. The way I'm reading that is you go to the row 2.1, and then the column gives you the second decimal place. This column says 0.07. Let me erase a little of this up here so we can see it. Right, so if this column says 0.07, that's telling you the second decimal position to use up here. So we're coming out that the z-score is 2.17. All right, so that's what we need to go ahead then and calculate n. So I'm going to put in 2.17 here for z, and 33.1 minus 33, that's 0.1. I'm going to multiply both sides of this equation by 4 over the square root of n. So 4 over the square root of n goes here. I'm going to multiply both sides of this equation by the square root of n now to cancel this out. So what I'm left with here is, I'll write it up here, 4 times 2.17 equals 0.1 times the square root of n. Now I'm going to divide both sides by 0.1. And so I have the square root of n equals 4 times 2.17, 0.1. Square both sides, so n is going to be this expression squared on my calculator. If I work this out, I'm going to get the answer 7535. Notice the instructions say round up to the nearest whole number. I'm going to work this out because I forgot to put the exponent 2 here. So I'm going to work this out on my calculator quickly here just to get n. And if I do that, I'm going to do 4 times 2.17 divided by 0.1, and then that quantity squared. So on my calculator, I'm ending up here with 7534.24. But notice it says round up to the nearest whole number. So what that's telling me is it doesn't matter what this decimal part is. I always round up to the next higher number. So 7535. Remember, it's not saying round to the nearest number. It's saying round up. So we always round up. Okay, so that's the sample size we need for this one. All right, let me see if we can do another example here. All right, folks, let me take a look here at another homework problem from Module 5. And if you notice here, they're telling us that the amount of time a drive-through bank teller spends on a customer is a random variable with mean 8.2 and standard deviation 4.5. And we're taking a random sample of 81 customers. Find the probability that the mean time is at most 7.2 minutes, more than 9, between 8.2 and 8.9. Well, the first thing I'm going to do here is find the mean of the sampling distribution. So if I want to know the mean of the sampling distribution for X bar, it's the same as the population mean. So that's 8.2. What about the standard deviation of the X bars? Well, that's the population standard deviation divided by the square root of the sample size. In our example, the population standard deviation is 4.5. The sample size is 81. So this is 4.5 over 9, which is 0.5. So now for part A, if I was to draw a diagram, by the way, notice we're working with the probability of the mean time. So we're really plotting X bars here. Well, this mean is 8.2. The standard deviation here is 0.5. And they're asking us to find the probability of at most 7.2. Well, that really means less than 7.2. So we want to find this red area. I'll color it in red here. Well, for this, I could use these tables, but a little bit of a shortcut is to use Excel, because Excel has a command called norm.dist. And I actually sent out an Excel file to help with this kind of calculation. And let me go to this Excel file. This is posted in course announcements. So let me come here. Let me try to get this side by side, I think. And I think I'm going to erase some of this here, just so we can get the Excel file next to this problem. All right, so let's go to part A. All right, well, in this Excel workbook, this Excel calculator, it says here, if you want to know the area under the normal curve to the left or the right, you type in the mean, then the standard deviation, and then the X value you're interested in. And then here is the area to the left, and here's the area to the right of that X value. All right, so let's do it. In our case, the mean is 8.2. The standard deviation was 0.5, and we want to know the area to the left of 7.2. So our answer is right here, 0.00. Let me highlight the answer here. We're interested in the area to the left in this example, right? Because when they say at most 7.2, that means less than 7.2. So we want this area to the left, which is 0.0228 rounded to 4 decimal places. All right, so that's part A. Let's go to part B. What's the probability that the mean time is more than 9 minutes? Well, I'm going to go ahead and change this value to be 9. This X value here, change that to be 9. And now more than 9 means we want the area going to the right. So in this example, I am going to be interested in the area going to the right. And the area going to the right is 0.0548. So that's the answer to this one. All right, let's go to part C. Part C is asking us, what's the probability that the mean time is between 8.2 and 8.9? Now, I'm going to scroll over a bit in this Excel file because there's a section here that says area under the normal curve between two X values. So I'm going to come here. I'm going to put the mean 8.2, standard deviation 0.5. I'm going to put the smaller X value here. It's 8.2. The larger is 8.9. And then this is the area between 0.4192. All right, so I'm using this Excel workbook to find the area under the curve. And I just had to make sure to use the standard deviation of the sample means. And remember, the standard deviation of the sample means is calculated taking the population mean divided by the square root of n. All right, folks, let me cover one more item here. Let me clear the screen. And let me cover one more item. All right, folks, let me come to an example here. And I wanted to show you the capability of Excel in using what's called descriptive statistics, which is a routine in Excel that calculates many statistical measurements for you at one time. So let me open up a blank workbook here. And let me go to this problem here. It says the company data set is the amount of phosphates per load of laundry and find the mean, median, and mode. So let me open up this data set. And here is the data set we want to analyze. I'm going to copy this to the clipboard. Okay, so I copied it. And I'm going to come here to Excel and paste it. And so this is the data that I want to analyze. Now, rather than try to calculate the mean separately, the median separately, the standard deviation separately, I can come to Excel and come up here to data, clicking right up here, data. And over on the right-hand side here is data analysis. Now, if you don't have data analysis available, you might need to install what's called the Data Analysis Tool Pack in Excel. And this is a free installation. You don't have to pay for this. And I'll post a video on how to install this if you don't have it available. It just takes a minute or two to install this data analysis tool. Once you do that, you're going to have this data analysis tab available up here. So I'm going to click on that. And when I click on that, it opens up this menu of different analysis that we can do. So there's things like histograms, regression analysis. Some of this we're going to be using a little later in the course. But for right now, I want to come here where it says descriptive statistics. And I'm going to say, okay. And the first thing I have to do is tell Excel where my data is. Here it says input range. Well, our data is in cells B2. So I'm just going to highlight these with my mouse. B2 to B13. Whoops, excuse me. So I typed in here B2 to B13. And I'm going to come here and click Summary Statistics, because that's what I want. I want a summary of this data set. I want things like mean, median, standard deviation, and so on. And I'm just going to say, okay. And Excel is now giving me a set of statistical measurements, like the mean, 32.58. So for example, that would get me this answer right here. The median is 30.5. So that's getting me this answer right here. The mode is 25. So here's the mode being 25. You know, this question might also ask me, what's the standard deviation? Here's the standard deviation. Here's the minimum in the data set. Here's the maximum, and so on. So this gives you a nice quick summary of that data set just using one command in Excel called this descriptive statistics routine. All right, folks, hope this is helpful as you're working in the Module 5 homework.